I'm Yue Qilin. Here I'm going to show you the solution of question 1 of homework 5. Homework 1 tells us xy are independent and the little PDF of fx and fy, and also tell us z equals x plus y, and ask us find out the little PDF of z and by two methods. The first one is the convolution method, and the second one is the geometric method. From the condition of the problem, the problem provided us the problem tells us how to do the convolution, and through this formulation, and at first we have a review of the convolution approach. Now here is the full step of the convolution. The first, write x and the edge on top, flop one of them, and add a t and slide it. This is the method provided in the lecture. Now we are going to solve the convolution. At first, we can get the figure of these two functions. And the first one, fx and fy. And then we change them into the tall, and we flop one of the function, and then add t to this function. And now we have to slide this function to another function that is like this. We can easily find that when t is less than 1, that means the figure of this one has not already slide to this one. So the little PDF of z is equal 0. Now let's move on to the situation. Now let's continue to slide the function, and that the t will at the right of 1. It will have an area that now let's continue to slide this function to this function. When t is larger than 1, and these two functions will have an area that is like this, the shade area. Now let's can make an integral in this area. That is now we can, so that we can get the little PDF of z. That is f z equals 1 to t, and the function is 1. The value of the function is 1, in the d alpha. And now we can get the little PDF in when t is between 1 and 2. For the same reason, when we continue to move the first function to the second function, look at the figure. Under this situation, the minus 1 plus t is larger than 1. That means that t is already larger than 2. T is moved to here. So under this situation, t is between 2 and 3. And we can make an integral of this shade area. We can get the little PDF of fz. That is between an integral between -1 plus t to 2, -1 plus t to 2, and the value is 1. And d alpha, we can get the little PDF of d between when t is between 2 to 3. Now that we get the little PDF of d in the 3 situations, we can write them together. We can get little PDF of d equals d minus 1. The t is d minus 1 from 1 to 2. That is 1 to 2 can be write into the step function of 1 and d minus 1 minus step function of d minus 2. And for the same reason, we can write the second period of this function into 3 minus d and multiply the step function of d minus 2 minus step function of d minus 3. And at the end, we can get the final answer of the little PDF of d. Now let's come to the geometric method. At first, we should review the condition we've got in this question, and from this condition, we can draw the figure of these functions. That is like this shape. To pay attention, this line is x plus y equals d. For we don't know what is the value of d, we should make a discussion. And also pay attention that the question asks us to find out the little PDF of d, that is f z, this one. And the solution to this question is to find out the right area and make an integral in this area. And we will get the large fzz through the integral. And by differentiate the large fz, we will get what we want to get, that is the little PDF of fz. Now let's begin from when z is less than 1, the little PDF can be 0. And when z is between 1 and 2, that means z is less than 2, and it's like this situation. Z is less than 2. The shaped area will be like this one. From this situation, we can get y is between 0 to x minus z minus x. This line is z minus x, and this is y equals 0 in this shaped area, and x is between 1 to z. And we got the integral from 0 to z minus x and 1 to z fxy dy dx. And calculate the integral, we can get the expression of a large PDF of z, and then differentiating the large fz, we can get the small PDF of z is z minus 1. Similarly, when z is between 2 to 3, we can get the figure like this. not this line. This line is x plus y equals z, and what we need to get is in fact is this area, but we use the whole square area minus this triangle area. We will get what we want to get. So that is the whole integral of the square area is y is between 0 to 1 and your x is between 1 to 2, fxy dy dx, and we will get the integral of the square area. Now we are going to get the integral of the triangle area. The integral of the triangle area will be this line. Y is between this line to 1, that is z minus x to 1, and x is between z minus 1 to 2, that is from this point. This point is z minus 1 to 2, and the integral is z minus 1 to 2 and z minus x to 1, fxy dy dx. And calculate, we can get the expression of large PDF of z, and then differentiating the large f z, we'll get the small PDF of z when z is between 2 to 3. Then write them together, we can get the same answer as the answer we worked out from the solution 1.